Consider this physics question. In order to convert a galvanometer into an ammeter, we have the option. A low resistance shunt is connected in parallel. That's option A. Option B, a low resistance shunt is connected in series. That's option B. Now option C, a medium resistance shunt is connected in series. Option D, a high resistance shunt is connected in parallel. And E, a high resistance shunt is connected in series. The correct answer to this question is option A, that is, a low resistance shunt is connected in parallel. But let me explain that. First, there are some instruments here. First is galvanometer, and the second one is ammeter. A galvanometer is an instrument used to measure small, very small amount of current. So it can measure high current due to its program. So if it measures high current and it has full deflection, it can damage the instrument because the maximum it can take will be read through its maximum deflection. So there is a pointer in the galvanometer, so indicating deflection. So most times we always use galvanometer to detect small amount of current, not even to measure current like that. So we use it to detect whether there is current flowing through a particular instrument. So that, but small amount. Now, however, this galvanometer can be converted to ammeter. Now, an ammeter is another instrument used to measure current, but this ammeter can measure large current. So most times in circuits, in most of our circuits that we use in physics, we always use ammeter because it can measure large amount of current. Now, so similarly, this galvanometer can be converted to a voltmeter. So a voltmeter is an instrument used to measure potential difference or EMF of a cell. So, but there is a difference between the two. How will you do the two? To convert a galvanometer to an ammeter, we need a particular type of resistor called shunt. So to convert galvanometer to ammeter, we need shunt. Shunt is a resistor. So this resistor must have low resistance. It must have low resistance. And secondly, another fact is that we have to connect it to the circuit in parallel. So why do we need low resistance? Because we don't want the shunt to alter the current flowing in the circuit. We don't want it to have significant amount. Though it will take some amount of current, which will enable the galvanometer to also take its own amount of current, so that it will not alter the rate of flow, it will not alter the current flowing in the circuit. So we need shunt for that, and the shunt has to be connected in series, so in parallel. So that, and let me make a small drawing of that. Let me make a small drawing for you to get it very well. So if this is the source of EMF in a circuit, so and it is connected to, so there has to be a galvanometer connected over here. This is the galvanometer, and the shunt will be here. So don't forget that shunt is also a type of resistor. So it will help us, since this connection is in series. So the current coming from the source of EMF, which is the cell, this current, as the current gets to this junction, is going to split into two. Galvanometer will take its own current, which indicate that one as Ig, while the shunt will also take its own current, we indicate that one as Is. So the current that will go to the shunt will be more than the one that will go to so that the galvanometer can only take small. So by so doing, we have converted this galvanometer into an ammeter. So the galvanometer will be able to take more current than this. So that is how. But however, to convert a galvanometer to a voltmeter, we need an instrument called a type of resistor called a multiplier. So this multiplier has to be connected in series with the galvanometer to convert it to a voltmeter. But in this particular question, our concern is galvanometer to ammeter. So the correct answer is option A. Thank you.